All right, ladies and gentlemen, today what we're going to be doing is kind of reviewing factoring a little bit to kind of make sure that we're all on the same page with how to do all the different things that are involved with factoring. It's going to be a very, very important part of Algebra 2 this year that we make sure that we know how to do this, okay? So the first thing that we're going to look at is how to take out common factors, otherwise usually called GCFs, how do we take out greatest common factors, and this is always going to be the first thing that we want to do when we go to factor something. So when I look at these, what I'm basically looking for is what is the largest thing that goes into every term in what I'm factoring. So for example, number one here, I look at this 6x squared and this minus 4x and I say, all right, what is the largest thing that goes into both 6x squared and negative 4x? In this case, it's going to be 2x. So I take out a 2x, and then whatever is left over is what I write in parentheses. So if I take a 2x out of 6x squared, I get 3x left over there. Remember, basically what we're doing is dividing this by 2x. And we'll divide this by 2x, and we get minus 2. So this one factor would be 2x times 3x minus 2. If you want to check your work and make sure that you did it correctly, you could redistribute this back through and make sure you ended up with what your original answer was, or what you originally started with, okay? Down here, we'll do the same thing. We'll look for a GCF. Now, you might look at these and say, oh, they're all even. 2 is going to come out of them, but we actually can take out something a little bit bigger. We're actually going to be taking out a negative 4. The 4, because that's actually the largest number that goes into 4, 12, and 16, and I'm taking out a negative because my first term is negative, and whenever I factor out, I want my first term of whatever is left over to try to be positive if possible. So I take out that negative 4, and I'm going to be left with x squared minus 3x plus 4. Okay, and that's taking out that GCF of what I can take out there. Down here, we actually have a GCF. It might not look like we do, but we do. Because these are being multiplied, this actually is one whole term, and this is also a whole term. So the thing that's going to be the same in both of them is actually the x minus 2. So I can take out an x minus 2, and then what I'm going to be left with is 2x plus 3. That would be what would I be left with if I divided both by x minus 2. Now, pay attention to this last example here, because when we talk about factor by grouping, this is one of the steps that we're going to see. So it might be a good idea to kind of come back and look at this one to kind of see how that works. Now, when we go to factor trinomials, there's going to be a couple steps we're going to follow. The first thing is what we just did. We're always going to look for GCF, okay? So no matter what, we always look to see, is there a GCF I can take out? The next thing we then look for is if there's a special factor pattern, which we'll talk about those a little bit later and we'll deal with those, okay? There's kind of a special kind of thing that happens that we then can use. The last thing we then do is do the factor by grouping, or if you like to do factor by guess and check method, you can do that as well. I'm going to be reviewing how to do factor by grouping here in a moment, because that's kind of a foolproof way that works every time. But if you like the guess and check method, that can kind of be a little bit faster if you're good at looking at it and doing it that way. So our first example here, 2x squared plus 5x minus 3. Let's kind of go through each step and see what we have and what we need to do. Do I have a GCF? When I look at these, 2, 5, and negative 3, they're only x in the first two terms. I do not have a GCF. I don't have to do that. Is this a special factor pattern? We'll be reviewing those a little bit later, but I'll tell you for right now, no, it is not a special factor pattern. So that means we're left with just doing grouping or guess and check. Just as a quick review of how to do factor by grouping, what you're going to be doing is you're going to first look at your first term and your last term, and you're going to multiply those two together and write down what that is. In this case, that's negative 6. We're going to kind of ignore the x's for right now. Really only the numbers, the coefficient, and the constant matter here, okay? Then what we want to do is we want to take this middle term, this 5x, and we want to split it into two numbers that multiply to negative 6, but they add up to this 5x, so we keep it there. In this case, the two numbers that I can think of are going to be 6x and negative 1x. Okay, so 6x and then negative 1x or negative x. So if we think about it, okay, 6 and negative 1, that will add to 5, and then 6 times negative 1 will multiply to negative 6. Once I've split those in this way, I'm then going to take a GCF out from the first two terms and a GCF out from the last two terms. So in this first two terms, 2x would be my GCF, and then what I'm left over with is x plus 3. And then from the last two terms, the actual thing I want to take out is a negative 1. Remember, there's secretly a negative 1 hiding here, and that's in both of these. And what I would be left with is x plus 3. If you factored correctly, if you did this factor by grouping correctly, these two should match. And that's actually going to kind of go back to that. Oh, I don't want to do that. Well, I guess I can. We're just going to go back. But I want to show you, it's basically this example right here, right? You have this thing and you're taking out that x minus 2. That's what we're dealing with here. We have this x plus 3 in both. We're going to take that out. So I'm going to end up with x plus 3 times 2x minus 1, because that's what would be left over after I take out the GCF, and we just successfully factored by doing the grouping method, okay? I would like you all to go ahead and try these three. We have 3 different trinomial problems, meaning as 3 terms. I want you to factor these by either using grouping or guess and check, okay? I'll let you know right now, none of these have a GCF, and none of them have a special factor pattern, so it's really just, can you do the factor by grouping? So go ahead and try these 3, and then we'll meet back and see how we did and what we need to work on. All right, and we have our factoring answers here. So we have our first one. I got x minus 3 times x minus 4. 1 times 12 is 12. And I split this into -3, -4, and then went ahead and factored out and did our GCFs, okay? Over here, I got 2x minus 5 times x plus 3. Okay, 2 and -15 is -30. 6 and -5 will add to 1 and multiply -30. And then I took out a 2x and a -5. And then over here, same thing. 3 times 8 is 24. So I split this into 6 and 4. Ended up with 3x plus 4 times x plus 2. Now, if your middle step here looks a little bit different than mine, that is okay. Depending on the order that you wrote these two numbers in, your factors may look a little bit different there, but you should end up with the same answer either way. You might be in a different order. If you have x plus 3 times 2x minus 5, that means the same thing. It doesn't matter the order that you write those in, all right? Okay, now our special patterns. So here's our special patterns that we're going to be looking at. So there's 3 different main ones we look at. The first one is called the difference of squares. And basically, if I look at a binomial, this one only applies to binomials, meaning there's 2 terms, okay? If I look at it and it's a perfect square minus a perfect square, I can factor it into the square root of the first term plus the square root of the second times the square root of the first term minus the square root of the second, okay? A perfect square trinomial is when I have a, first of all, trinomial 3 terms, okay? But the first and last term are perfect squares, and then the middle term is their square roots multiplied by 2. In that case, it's going to be the first term square root, the second term square root added together and squared, and there's a subtraction in the middle, then they're subtracted squared, okay? We'll see some examples of these as we go on here. Last but not least, when we're dealing with a cubic, okay, this one's called a difference in sum of cubes. If I see 2 terms, again, a binomial, that are perfect cubes being added or subtracted, this is the factor pattern that they're going to go into. Again, we'll look at one of these in a moment here, all right? Let's kind of look and see how they work. So we're going to first identify the pattern, and then we're going to go ahead and factor. Now, we're still going to follow the same steps we looked at earlier. Look for a GCF, then look for a factor pattern. These all are going to be a factor pattern, but they're all going to be jumbled up, you know. And then the last but not least, we then try to do our factor by grouping, or we do our guess and check, depending on which one we like to do. So looking at number 1, I actually have a GCF. I have 3 that comes out of both of these. So I'm going to take out a 3, and then I'm going to be left with 1 minus 4x squared. And then alarm bells should be ringing in my head because these are both perfect squares. 1 and 4x squared are both perfect squares, so I can go ahead and do my difference of squares. 1 plus 2x and 1 minus 2x. The difference of squares, okay? Over here, I actually have a difference of squares as well. This x plus 2 is being squared. This -16 is a square. So we'll go ahead and do our difference of squares here. So I'm going to have x plus 2 plus 4, and then x plus 2 minus 4. And we're going to end up, we can simplify this a little bit further, with x plus 6 times x minus 2. All right. Last but not least, we now have our difference of cubes. This is one of our newer ones. So let's go back here and look at it. So difference of cubes, I have 2 cubes that are being subtracted from each other. The first thing I'm going to do is I'm going to subtract their cube roots. So in this case, that's going to be x minus 3. Then what that's multiplied by is the cube root of the first squared there are two cube roots multiplied and then the cube root of the second squared. So that's going to look like x squared minus 3x plus 9. Okay, so I just factored these three all by using my special factor pattern.